Hi everybody and welcome to 3D Print Tech Design. We moved, so I don't have the original studio, but hopefully you'll be with me today when I unbox this new 3D scanner. It's from BlackBox 3D, not the most commonly known brand as of yet, and the CAT or CAT-1. So this is a one-in-one 3D scanner. You have a turntable, you have a scanner, and you should be able to get some pretty good results from this. So I think it's time that we unbox this and see what's inside. Okay, so I'm going to try to use my kitchen table here. We'll see how that goes. We can kind of see the logo through here. So I'm not sure that we're actually getting two boxes. It might just be one. But let's see if we can start somewhere. It looks like there's a top up here. Okay, that's it for the first one. Let us... There we go. 3D scanner. Let's see, we have a serial number, we have a voltage, manufacturing, BlackBox 3D technology, made in China. Cool, very cool. Let us fold this down. Let's see if we can push this out. There's some... this is interesting. Okay, we're getting something out of a box. There's a lot of boxes here today. That's why we call it an unboxing. So we have, whoa, this is cool. This is some sort of, it feels like a mouse mat. But yeah, as you can see, this is actually the orientation of the machine. But it feels like a mouse mat. It's like really heavy. So that's cool. So that's to help us navigate where to put everything. And that helps with everything from aligning the scanner to calibration. We have a quick guide. That's very nice. A small quick guide. That's to help us do... Oh, we have two pages. We have another page here as well. This is to help us with the calibration. This looks very standard. We should see some stuff in here in the box. Ooh, this is interesting. We got some markers. These are markers to help reflect on items for tracking. I didn't know that this scanner actually had tracking on objects. So that's going to be fairly interesting to try out. And we also have it's a map certificate of compliance and all that kind of stuff. Okay, interesting. But I think that we actually want to get inside of this box. I'm going to be careful with cutting the tape here. We don't want to destroy anything. Now we should be able to open this up. Whoa, okay, that's cool. So we have the lid. Okay, cool. We have a few things in here. Let's start off with this one here. Oh, this is so cute. See, can I actually lift this up? Oh, we need to take this one first. There's an order. Okay, so first of all, we have the turntable. The Lazy Susan. So this is the turntable. We have a few connectors here on the back. Let's see, we have a 5 volt, 12 volt, a USB in, USB out, and also a USB port that is blocked, so maybe that's not supposed to be used. And then we have this alien looking head. So this is the projector and the two cameras, and this is what's made to generate the pattern that is then used for the 3D scanner to register. So you have two cameras looking inwards. It looks like some sort of alien. That's pretty cool. We have two cables here. We have the 5 volt and a USB. We have a calibration pad with a special pattern on. We have some sort of stand for that. What else do we have? We have USB, which I assume also holds the software. We have the 12 volt power supply. I wonder if this is my serial number, which is 000. That would be pretty cool. It's a standard power port in, so I can connect my EU cables here. That's nice. Speaking of which, I didn't get, but I got some other cables here. So you have one USB cable and one power supply. This is Chinese or UK, I'm not really sure. We also have our stand, which comes with a dinosaur. How cool is this? So we actually get a toy that we can 3D scan. and this is apparently a good test object, so we'll be scanning that later on. Last but not least, we also have the stand where we'll attach the scanner on metal. So that's going to be very good, a strong base. That's awesome, and that looks to be everything that's in the box. So I will go ahead and install the software, and I'll show you guys how that's done, and so I'll see you guys in the next prank. Alright, so this is the BlackBox folder that we get. We get an installation file. So funnily enough, the software is named Meow Meow, and the scanner is called CAT-1. So yeah, and you have the cats. Obviously they have a lot of fun at work. Alright, so this is the software. You can choose different languages, Chinese or English. I'm gonna go with English, and you can use a white or black interface. Open file, well, we can open up project, we can open up the point clouds and everything. In the rotate scan, we do exactly that. We rotate around the turntable to do our scan. Free scan is the mode with the markers that I was talking about. So that's pretty fun that you can use a free scan where you actually move the scanner around instead. So we'll be checking out that. And of course we can rotate the table. So if I would like to maybe start my model somewhere else, I can rotate it a few degrees to get where I want to. So I can say, for example, 15 degrees, it will rotate. In the center we have calibration, which is one of the most important parts. We'll go through that a little bit later, but it's basically just following this guide, putting up your marker here, or the reference plates. But yeah, that's not what we're going to do right now, because now we want to, for example, start a rotate scan. So in here we have a lot of settings. Let us go through them. We have the brightness. That is, you can see the cameras here. So with this object we would be probably around the 4. Oh, I should have cleaned the background. Didn't think of having cameras watching this the couch here. There are some very weird translations here, so hopefully you can see. We have the detail state, so this is how much of the scan points that gets into the mesh, into the actual STL or OBJ file. We have a sealing state, so that means that you're sealing the holes. So if there's any holes, it wants to do that. I think that depending on what you're doing, if you expect a good 360 scan, you can leave this on, but if you don't, I would probably leave it off, because you can always fix the point cloud files later on, or the mesh itself. Fill hole, we can fill the holes by curvature or by smoothness. Vena state is texture. Maybe my translation to English isn't that good, but I don't know why it's called Vena state. But that's what it is. And we have splicing mode, which is actually more the alignment mode. So in this case we want to use the feature because I don't have any marks on the object. Also we can change the scan time, so this is how many times we divide a lap on the turntable. So the higher, the more exact, the better it gets into all the small angles, and the better it will actually track on different scans. But for now we'll do something easier, like around 6. So you can of course turn off the texture and on. But yeah, I think that I'll do a example here. We'll use let's go with a middle. We'll smooth the holes, and we can do everything like that. Now if you want to, and you should do this when you're doing a scan, we can do a color calibration. So I'm going to take a white paper and put it in the cameras here in the field of view. Then I will click on color calibration. You can see now the green stuff here in the background actually became a little bit better. So that was the color calibration. Okay, so with that said, I'm going to do a calibration of the scanner. So let me just set it up. We will be using a little stand here at the 67-degree angle. I'm using some putty, some multi-tack. Is that what they're called? Tacking pudding? To try to hold this down a little bit better so it won't move. Then we need to take the calibration plates, put that in the middle, and actually we should go back into the calibration mode. Let's see, 2 or 3, maybe a 3 here, so all the dots are really clear. Let's click on collection. The scanner is now looking at these 2 targets. You can see that they have different angles depending on which camera is looking at them, and it's also moving them around to see how all of these dots moves. So with that, we are now supposed to move around to another angle. Should be this one. Yep. And as you move the plate, it's very important that you don't move the stand that it's standing on. And then the last state, there we go, collection. And of course, right now I have the scanner on my table. It's important that you don't move or touch the table, because there will be some vibration, which aren't very good for a good calibration, or a scanner for that matter. Let the computer think a little bit. Calibration is successful, awesome. So now we can do a rotate scan, for example. I'm going to move the calibration plate away, and you should be very careful about the calibration plate. You don't want to ruin it. I'm gonna take the dinosaur here. Brightness around 4. Let's do 6. No, let's do 6 scans. Let's use textures, ceiling, smooth. We did the color calibration, and let's start. So now we can see these lines on the object. Those are actually producing the mesh. It's the projector doing that, and then a color image. And we should have one frame. So this is one frame of the data, and those lines that you can see, they are actually producing this all these points. And again, right now everything is just points, but in time we will do a remesh on this one. So let's just speed this up, and we should have a full scan. So the more angles you have, the better the scan will be. But right now we've divided the 360 degrees into 6 scans, which might be a little bit little to get the details in all the angles. But what's good with this scanner is that you can actually turn your object around, and you will have a new opportunity to scan even more. So now it's optimizing this scan. So it's taking the images and or all the point data and trying to align them a little bit better. The scanning is completed. Well, no, the alignment is completed. So do you have multi-angle scanning? That means that we can actually move it around. So I will click yes. I'm putting the dinosaur on its back. That doesn't make sense. I'm going to put it on its side. And then we can click on this bottom here again to start another scan. So now you see that it's lying down, and I'm going to process all of these scans, and we'll have a look at it when it's done. So now it's optimizing this again, and it's also aligning it towards the other models. So it's asking me if I want to do more scans, but I'm going to click cancel. I can actually start again here if I want to. The legs are missing a little bit, and also so is the back. Let's just leave it, and let's have it try to fix these holes. A better scan, and you can see my other examples with this one later on, is to have much more angles. Then you get more data, a little bit slower processing, but you get better scan and better coverage. It could be that we happen to have to come in a shadow part here where the scanner couldn't see. The next step here is to, before you reconstruct, that's what this button means, I want to save, and you can save it as a starting point. Starting point is actually all the different scans as individual point clouds. So I'm going to go in here, take dinosaur 2, and if I save now in here, it will save all these sharding points. So that means that if we go in to look at that folder, dinosaur 2, we have 2 scans here. So this was the first one in one angle, and then we have the other one in another. So we have all of these 6 here. These are all individual scans, and the fun thing is that these include all the different points. So there's a lot of different points. You have all the points if you want to do a better reconstruction in some other software. So that's pretty fun. When we've saved that, we can now do a reconstruct. So that means that it's taking all of these points, there's millions of points, I don't think even the computer shows all of them, and create a mesh. It's doing some mesh optimization. And there we go. It actually filled all the holes, but of course we were a little bit quick, so we didn't get all the textures. You can also see some smaller defects like down here, but again, with more angles, you'll get a better results, as I will show you later on. Before we save this, we can of course save it as a STL. So save mesh, STL. I'm going to go into the dinosaur 2 folder, STL. That's saved, but before we save an OBJ, which includes the texture, we need to click on this button here. I'm not sure what it means, but it means doing some sort of texture. By the way, we can also cut out parts. We can select parts to cut out. We can redo what we just did. We can go back to home. We can fill holes. That will fill all the holes. We can change the colors. We can print it, which actually just sends it to a printer if you have that plugged in. I don't recommend that. You can just take out the STL. And then we can smooth the mesh out, but of course this is the texture button. So pay attention to the colors right now, and when I click on this one, it will think a little bit, texturize it, and now we have a mapped texture on the model. So usually it is a little bit dark, but I think that's mostly the rendering. When I look at this in other softwares, it looks much better. So now we can save a mesh again, and we can save it as a OBJ. So we had 482,000 triangles in this model. That's pretty decent. So I'm going to do a lot more of high quality scans, so we can check those out later. But let's go ahead and check out how the scanner actually works. Obviously, I scanned quite a lot of parts, and I thought that we'd check this one out. So you can see here, even the contrast are super good. I did scan this with texture and without texture, and it really performs well as soon as the object is pretty light, so the textures and the patterns are clear. So here you can see me spinning around the textured model. The rendering in Mesh Mixer isn't always the best, but yeah, looks pretty good. Also scanned this elk, I think it's called elk, yeah. I found it in an airport gift shop, and I thought that, hey, I want to scan this. So that looks really cool, and both of these models and more you can check out in the links down below if you want to spin around and download them yourself and check them out. I tried to scan an apple, and I didn't do the color calibration, as you can see, but also there's a little bit of mismatch because it's very smooth, but so it's hard to track on. It did well, but it was very hard to do a good scan on that. And the same on this sweet potato. It was easy enough to scan. I would get some good data in, some good data points, but having all the scans aligned without the markers ended up with this dual potato inside out. I did do some better attempts, but then I still didn't get the calibration perfectly. Also, I tried to scan this pine, and I didn't get a lot of data, and when it fixed it didn't really work as planned. So those are a few ones. You can check out more in the links below, and yeah, let's continue. Okay, so now when we've unboxed it and set it up, it's pretty simple to set it up. It's time to just have a look at how the scanner actually works. So we have two parts, of course. We have the turntable and we have the scanner itself. And as you can see, the scanner consists of a projector and two cameras. So these two cameras see a projected light on two sides, and that means that the projected light will actually bend over surfaces and deform. So by looking at how this pattern bends and behaves on the surface, it can triangulate and create an 3D depth image. So basically what happens is that when you click scan, it does this pattern. Hopefully you can see it. It moves all the so when it's done one image, it turns around, does another image, and it keeps adding these points and adding several images to create a fully scan. And then you can of course turn the object and create more scans, adding depth data to the object. So I think we should continue here. I'm going to stop the scan. There are some objects that don't fit in the turntable volume, so you can actually use the scan mode called free scan. And within that mode, you have to move the scan around, or actually move the object. And you need to put some markers on the object. These are reflective markers with a certain roundness or a certain diameter. So they are accurate so that the scanner knows exactly how far away they are and how many dots they are. So in the free scan mode, you basically remove the turntable, but you still have to have it plugged in because of the cables. So I usually put the scanner on it, and then we can start scanning by taking one image, overlapping the points, and continuing. So I'm gonna just set it up here a little bit differently, and we can check that out as well. Okay, so as you've seen, I've set it up a little bit differently. I put the scanner on the turntable, and instead I have the object here where I put a lot of markers on. This is a quite dark object, at least for the scanner, so I've done some tests before recording this, and it's not going to work out perfectly, but I want to show you the process, and then I'm going to move the scanner to some other objects that should be a little bit easier to scan. So in this software, we are going to click on free scan, wait for that to load, and then I'm going to go with something more middle. I don't want to seal this to a watertight model, and I don't use the VNS tape. So I'm just going to go ahead and click on scan. You can also see here that we have some dots marked red. That's good. It means that it's actually seeing those dots pretty well. So let's go ahead and make a scan. So you can see the pattern moving over the surface. I think it's quite low actually. I can hardly see the contrast. Here we are, the software is collecting the dots. Okay, this is really fast, so let's just freeze this frame. So in this frame you can see the right camera and the left camera's image. You can see that all the markers are registered, so you can see all the blue ones, but it's then using the red ones that has a little number in them. Uses the red ones to correlate between the two cameras. So a good sign here is that you can see several of your points in the picture, but that the scanner and the software also uses as many as possible to align the two cameras together. And here we can see the scan surface. So we are missing quite a lot, but I'm going to turn this a little bit and take another image down here. It is not the best object. I know it's very hard for the scanner to figure out. So you can see it's getting more dots. We are getting more data in our scan. So I'm going to continue here a little bit. But yeah, the downside here that we can already see is that it's very sensitive for dark objects. The projector has a very low light. So I'm going to continue doing these a few steps, and you guys can check out the speeded up process. Okay, so you can hardly see here, but I want to raise the scanner up a little bit. So I'm going to use these two boxes, kind of get it up. And so I've stated before, I should really print some sort of support, because this support is not very good at all. So let's take a new scan. It's very unstable up here, so I need to be a little bit patient and not move as much. Let's see here. It should track pretty well. That's the whole point now, that you can move the scanner around as long as there's overlapping dots. It should be fairly simple to get more data basically from more angles. It is a slow process. You can see on the mesh that it's working hard. Again, I want to just finish this dark example, and then we're gonna take some walls and some more interesting stuff to scan that is a little bit easier for the scanner to handle. Okay, I think that's enough. I'm gonna click on scan end, and it's gonna optimize a little bit. So let's check in a few seconds. Okay, so as you can see here in the data, we are still missing quite a lot, actually, especially on these sides. But we are starting to get some sort of patterns here. And if I would have continued a bit more, but I'm a little bit patient, or if I would have sprayed this box with a white spray, we've had a much better results. So I would say that this is hardly okay, hardly approved, as this object is not that dark. So yeah, let's try this on something a little bit brighter first. But before we continue, I just want to show you here that you can save this as a point cloud. So even though if you're not getting a great mesh, you can still use the point cloud to get all the noise that you can see. You can find out where the ridges are in all the different parts. So we can save this. What we can do is actually save the shutting point. So that's actually, yeah, so we can save the points in here. And that should be at least something to go. Let's check those out first. So in this folder, I now saved all the different points clouds. So these are actually as coordinates. So you could load those in and check out the data. Because when we do a mesh on this one here, or a reconstruct, it will of course load a little bit, but then it will kind of remove a lot of the noise, which is good. But in this case, I'm trying to save a worst case scenario. So you can see it cleaned everything up, but we're also missing some of the helpful points that would tell us where things are. Again, for the application, this is of course not a good scenario or outcome, but you could still use it for it. You could still, with a little bit of tinkering, you can figure out where things should be in this box, if I scan more of it, of course. So let's just move out of here. We could save the mesh for later as well. So I'm just saving an OBJ there. We could save STL as well. And let's go to another example. Okay, so we moved over to well, our entrance, but we have some weird walls here, so I thought that this should be a much better scenario for the free scan to see if we can measure all this stuff. So in the software, you can see, I can now see clearly the points here. I'm actually going to move the scanner around a little bit so we can see more of those points. And I think the exposure is good, so I'm just going to click start. You can see here on the computer screen all the lines of the scanner is much more clear. Let's figure out the dots. You can see the overlapping ones, and bam, we got a great surface on the first scan. So we want to move this around a little bit. Make sure we still can see all the dots. Click on another scan. Yeah, you see we have overlap of the dots. That's super. Let's see if we can get even more into the corner. It doesn't really matter how far we go. We'll still have a blind spot in here because we won't be able to reach there with the scanner. But so far so good. I want to continue here a little bit. Just grab as much data as we can. But the scan is looking really good. You can even see the texture on the wall. That's actually very impressive. There are a few small paint dots that are visible in the scan as well. It's great, we're getting good overlap on all the dots. And if I need to, I can actually just add more of these reflecting dots. That's a great overlap. I'm going to be able to move this scanner quite far into the corner and still see all of this data. I'm actually pretty impressed. Now again, the floor is a little bit reflective. Oh, we can even see the screw head. Let me zoom out a little bit and see if we can get more of that. There's a screw in the left side of the image. I'll try to get more of that one. Okay, let's see if we can raise up the scanner a little bit, see if we can get more of that floor in a better angle. Still need to see all the dots. Click on scan. It's quite quick, but you can see which one's overlapping. That's awesome. We have good overlapping. Awesome. Okay, let's call that the last one. I think we are ready to check this data out. So I'm just going to process this, but you can see we have a very good profile. Here is the shadow area I was talking about. But this should be fine to do some sort of measurements on, and we'll go into Fusion 360 and do that a bit later. But first, let's process the data. So we are going to click End Scan, and I'll just get back to you from a different angle. Alright, so here you can see the refined data. It's still not meshed, but I think this looks really nice. I'm going to save all the points cloud. That's called a sharding point. So that's many different point clouds. Because we could mesh this in another software. Because the problem is now when I scanned it, there's no way for me to change the details in the meshing, which I think is also a feature I would like to change. Okay, let's click on Reconstruct. So we'll create a tight mesh. So here you can see now we have a little bit of medium meshing, but it's still good enough to see where we had the screw, for example. This is some sort of Phillips screw. We also have a few dots in the paint, which I find pretty cool that it's actually getting that data. But I will try to mesh the detailed, the raw point cloud in some other software just to see if we can extract more data out of this model. But I think this looks really cool. So we're gonna save this as a mesh, call it wall section, save that as an STL, and we can take this in and just do some measurements. Maybe if we wanna renovate here or build some part or print something, we can use this data for our own good. Let's move on to the next chapter. Alright, so I hope that this video helps you get an overview of the scanner, see how it works. If you want to check out the samples in more detail, you should check out the link down below that leads to my website, where you can find a lot more information about other scanners, about 3D printers, about technology, and a bunch of cool stuff. So make sure you check out, and while you're down there, make sure you subscribe. There's like 2% of the viewers are subscribed, so I mean, come on, you gotta subscribe. It's on that button as well. And leave a like while you're there. My final words about the scanner is that I think that it's a good entry level, but there are some things I would see updated in software, maybe even hardware. So if we're talking about the hardware first, I would love to have a bigger scan volume, but I think it's quite optimal actually. It fits most objects in here. Of course, you can use the free scan mode if you want to do a little bit bigger things. Second thing is that I want the tripod support to be much better. It is a bit flimsy, which means that you kind of have to calibrate it every time you use it. You can, of course, bolt everything down, but that's not really a good situation. So I would like some more stability to avoid some calibrations. Also, of course, the projector could be a little bit stronger, so it would be better with dark objects. Speaking of the projector, I think you could be able to change that in software, so hopefully there will be a software update where you can do more processing of the data, more changing of settings during prints. For example, there's no way to change exposure in your free scan. So if I have a darker and a brighter area, I can't adjust that in the same scan. I would have to stop the scan and use some other software to combine the data. And yeah, speaking of data, that's always where we want to continue with 3D scanning. All 3D scanning delivers a mesh file, and with the BlackBox CAT-1 scanner, you can of course do the 3D printable ready files with the watertight or the sealing states. But I would, of course, if there were possible, I would like more options to create better applications, fill selected holes and do smoothing and stuff like that. But there's a bunch of free softwares like Mesh Mixer where you can do it, So I don't expect it from a scanner of this price, but it's nice to have. So yeah, my final conclusion is that I think it's a good scanner, but there are the drawbacks of the darker objects and also the flimsiness of the tripod. But I mean, if you have a 3D printer, that's very easily fixed, which I will do in a video coming sometime soon. So check out that subscribe button and you'll see that video too. At its price points, which you can also see in my article down below, I think it's a decent scanner. It's not the best I've tried, but on the other hand, I worked with $20,000 scanners, so of course it's not the best, but it's definitely not the worst either. It's a fun little thing, and I'll be using it more. I'll be doing more projects on the website and 4 videos. Yeah, hope you enjoyed this video. Check out the links down below. Let me know if you have any questions about this scanner or other scanners, or in general anything regarding to 3D printing, tech and design. That's all for today. Thank you so much for watching. Yeah, I'll see you guys in the next video. Bye!